Alrighty, so this is going on page 46. We're going to do some of this together. You're doing it, most of it on your own, or together on your own without me. You'll be fine, because this isn't really new, okay? We have looked at units with derivatives. We've looked at derivatives in context. Then we did the PVA stuff with straight line motion, either going left and right or up and down. And so now we're going to use basically other contexts. So we're going to look here at example 1. And if you notice on after each example, like number 2 says calculator active. Example 1 does not. Therefore, example 1 is not a calculator question, right? We got to be able to do it without the calculator. So let's read what this says. Speedville High School opens its doors for students at 8 a.m. each morning. One particular morning, the number of students inside Speedville High School can be modeled by this function, where t is between 0 and 8 minutes since the doors opened at 8 a.m. Find the rate that the number of students inside Speedville High School, I can't say that, is changing at 8:03. So we want the rate that the number of students inside Speedville High School is changing. So they give us P of t, right? Okay. So this is what we have. Do we want P, in order to find the answer, do we need P of t, P prime of t, or P double prime of t? What do you think? Prime, okay? Because P of t, this is the number of students. That's what this is. If we want the rate that the number of students is changing, so it's students, P of t is just blah, blah, blah students. P prime of t would be students per minute, and P double prime would be students per minute per minute. That would be the rate at which the rate is changing, right? But that's not what it's asking us for. It's just asking us for the rate. So we have P of t. That's what we have, okay? So we have to pay attention to what we have and then what we need, right? So we need P prime of t, non-calculator. So I have 25 times the natural log of 3t plus 1. What process, derivative process, rule, whatever, are we going to use to take the derivative here? Chain rule, okay? Because we don't just have the natural log of t, it's the natural log of another function. How do you take the derivative of any natural log? 1 over whatever we're taking the log of, right? And so this is going to be 25 times 1 over 3t plus 1 times, what's the derivative of 3t plus 1? 3. So this is really 75 over 3t plus 1. Do you agree with that? And there's nothing wrong with when you take the derivative, go ahead and you don't have to just put 1 over that. You could have put the 25 over this, and you could go ahead and put the derivative in the numerator, but I just split it up so you could understand where everything's coming from. We all good? All right, so then what do we need to do next? Substitute, okay? So I need P prime of what? 3. That's going to equal 75 over 3 times 3 plus 1. So what's 3 times 3 plus 1? 10. Okay, now could I leave it like this? I could totally leave it like this. We'll go ahead and finish it. But we get 75 over 10, which is 7.5 what? Students per minute. So then we can say the number of students, and then we want to make sure that sometimes it would say like entering at this rate or what, this says inside. So the number of students inside, we're assuming they're entering somehow. The number of students inside Speedville High School is changing at a rate of 7.5 students per minute And you can write in words students per minute, or you can write it as units like that. Is that the end of my sentence? Is it always changing at that rate? At t equals good. At t equals 3 minutes. Okay. See how it's basically the same concept as PVA? It's just not about a particle moving back and forth. Any questions at this point? All right, so let's look at the calculator active one, but we're going to talk about things before we worry about the calculator. For TB between 0 and 10 days, the rate that a company sells T-shirts in hundreds of shirts per day on its website after an appearance on Shark Tank is modeled by this function. At what rate is the rate of T-shirt sales on the website changing? So at what rate is the rate of T-shirt sales on the website changing? So they give me S of T, right? Am I going to use S of T, S prime of T, or S double prime of T? Okay, S double prime, why? It's the rate of the rate. What does S represent here in this question? Read that question. What does it say? The rate that a company sells the shirt in hundreds of shirts per day is this. So are you sure we will S double prime? Isn't S a rate right now? S is not the number of shirts, right? Okay, now there's no prime on that S. I get it. But just like if I gave you velocity, there's no prime on that, but isn't that the first derivative of position, right? So be very careful, because you're right. As far as if this was just that pure math, it is a rate of a rate, which we've got to catch. But what this is a rate. This is in, and it tells us hundreds of shirts per day. So this is already hundreds of shirts. Oh, goodness. Shirts, pretend like there's an S there. Per day. We want hundreds of shirts per day. We want the rate of the rate. So do we actually want S double prime? No, we just want S what? Prime of T. We have to find that, and then we actually want S prime of 5, right? Does that make sense to you? Okay, so I don't want to go through every single one of these with you and step you through it. I want you to think about them and get through them, which I totally think that you can after what we've been doing, okay? So I want y'all to work on these together. I want you to ask me questions. If you get stuck on things, I will verify things for you, but I'm not going to just stand up here and do it, okay? We good? Awesome.